So again, good morning to everyone.
Good morning.
And I believe that most of the participants, they are at postgraduate level. And I believe that some of you may be working as a faculty and some of you may be doing your PhD also. It means that we have very mature participants, and considering your background into account, I will try to make the lectures more interactive and to have more active participation from you also, so that I can also learn from you and whatever background you have. It is a mutual process, and we know that teaching is a lifelong learning process. So this course, which is a 5-day course, in which the main focus is on sustainable energy system. We know that so in this course, the key focus has been, while developing the proposal, we thought that we have to utilize sustainable energy technology for the sustainable development of the society. Considering that high-level objective into account, Dr. Farooq, he approached me and he initiated the discussion that if we integrate AI, artificial intelligence or machine learning for achieving the objective of sustainable development, then it will be really a good proposal for getting it approved. So after having deep conversation and discussion with Farooq, we developed this proposal in which we are trying to learn that how the sustainable energy technologies implementation can be facilitated using artificial intelligence. All of us, we know that India has signed the agreement for being the part of United Nations Sustainable Development Goals. If we consider United Nations Sustainable Development Goals, there are 17 goals. In this course, we will try to focus on Sustainable Development Goal 7, which is clean energy access for all. Then it comes the sustainable technology, and then United Nations Sustainable Development Goal 11, in which the focus is on infrastructure. So for doing the infrastructure and getting it integrated with sustainable technologies, we have to use artificial intelligence. And then last goal, Sustainable Development Goal 70, which is correlated to co-creation of knowledge. It means that you have to work together in an effective manner. That's why we have this GAN course using international expertise and taking into account the national expertise also. It means we are co-creating the knowledge together for Sustainable Development Goal 7. So overall, this planned GAN course is going to contribute effectively on achieving United Nations Sustainable Development Goals. Now, our focus on my background. So let's come to my background. I am working on sustainable energy technologies from last 3 decades. Most of my focus has been how we have to develop sustainable energy technologies. For example, solar photovoltaic system, hydrogen energy technologies, electric vehicles, and energy storage. How we have to integrate them together, right? So that we can contribute towards the Sustainable Development Goal 7, where we have the goal of clean energy access for all. So I have given you a very high level overview of this course, and when we are talking about these sustainable energy technologies, we know that most of these technologies are nature dependent. Their output is going to be very intermittent in the nature, and then when we want to integrate them for reliable sustainable energy supply, we need to have appropriate control system, and to have this appropriate control system, we need to use information communication technology for integration. And when we are using ICT technologies for integrating them, we are going to create huge number of data, and those data will be collected, and we have to process that data, and based on that we need to find out appropriate mechanism for managing and controlling the power output from this nature dependent sustainable energy technology, which is going to be possible by using artificial intelligence or machine learning. Okay. So that is the key point. So related to my academic background, Dr. Farooq has already shared with you about some of my academic background. In last 3 decades, I have worked in many countries, and overall the focus has been on sustainable electrical energy system engineering. During these 3 decades of experience, I have the opportunity for developing, creating new courses with focus on sustainable technologies for undergraduate and postgraduate programs at the world's leading university. And all of us aware that when we want to do the teaching, at the same time we have to contribute in research also. It means that we have to teach the young researchers for doing their work related to the domain knowledge which I have, right? So that most of the focus of my research grants have been on sustainable energy system engineering. Okay, so that is a very high level background about me. Now coming back to the focused background about me, because you should be aware that, and some of you are quite young, or most of you are quite young, right? So you need some encouragement also, and you should also learn like how the academic journey it works in the international context. So at this moment, I am working as full professor in smart grid and renewable energy at the University of Agder, Norway from last 12 years. That I have not listed here, but Farooq has shared some inputs about that. So before coming to University of Agder, Norway, I was working at University College London, and University College London is one of the world's premier institution. And some of you may be aware that Mahatma Gandhi, Rabindranath Tagore, they were the alumnus of University College London. And University College London has more than 25 Nobel laureates in the credit. So the work which we do at UCL is always at very world-class work. While working at the University College London, my responsibility was that to establish new school of energy and resources in which we need to develop new postgraduate programs for sustainable energy systems, especially for the industry professionals, and taking into account the multidiscipline approach. So here, the word came now, the multidiscipline approach. So here, with the help of this multidiscipline, I will explain that how the different knowledge domains, they can work together for sustainable energy system. So while working as Director of Program and Senior Lecturer, which is equivalent to full professor in many of the universities, the multidiscipline energy program which we developed, in which the students were not from engineering background, but some students, they were from the background of economics, energy law, sustainability, environment, etc. Because we know that when we are developing the leaders for sustainable energy system, so the leaders should have the multidiscipline capabilities. They should be in a position to learn or to understand how this different domain knowledge, they can work together in integrated manner for sustainable technologies implementation. Right. So here it is a really big challenge for an engineer to teach to the students who are having the background of economics or the law, right? Because they don't have that engineering background. So it's really very challenging also, and also to engage them, like to understand how these different technologies work and how they can use their domain knowledge together. So in this course, we are trying to use some concept of energy technologies here and putting it with the help of machine learning. Right? So it is going to be a multidiscipline approach. So that was really a very good experience for me for developing this master's program in sustainable energy, in which the participants or the students were from different disciplines. And then at the same time, while working as a director of program University College London, I had the opportunity for being the board member of South Australia government's first renewable energy board also. So I have contributed heavily on developing renewable energy policies for South Australia, and in which we tried to integrate energy domain knowledge with energy economics, policies and planning. I feel very happy to contribute for that, because some of you may be aware that South Australia is running many times on 100% renewable energy. Right. So you see, I was there, the board member from 2009 to 2011, and now at this moment you can see that South Australia is running many times in a year on 100% renewable energy. So the policies which I have contributed at that time, now they are taking the shape for the implementation also. Okay, and now you may be aware that South Australia has demolished all coal-fired thermal power plants. Now it is running on the wind, solar, and for the peak load, gas-fired power plants also, and it has the integration or network integration with neighboring states also. So that was a wonderful experience for me also to learn that how the renewable energy policies should be developed, right? And how that learning can be implemented within the economy, for example, like our Indian system also, right? We know that Indian government has agreed that by 2070, right, 2070, we will be achieving net zero. And many of the developed countries, they agreed to be net zero by 2050. It means that, what does it mean that? It means that we have to focus on getting more and more sustainable energy technologies integrated within our energy network, right? And to achieve that target, we will need some young generation and professionals who have not only the domain knowledge, but to integrate them within the energy system network. Sometimes we call it as a smart grid system. And when we are talking about the smart grid system, so within the smart grid, we have to integrate information communication technologies, IoT systems, and many things together, right? So then we will need different domain knowledge together also. And then when we are integrating all these technologies together, so of course they are going to impact the business models of the energy companies, or existing business models may not remain valid when we are moving towards the net zero. It means that we need to work on developing new business models also. Okay, so you see, then we will need to include the persons who are having the energy policy and the energy economics background also for developing the policy, appropriate policy, right, in which, right, the companies or the organization who are working on sustainable energy technologies, they can also get the profit also. So in many of my research projects and some of my PhD students also, they did their research work on this topic also, and slowly within this course we will discuss all of them so that you can also learn and I will also learn from your background also. So now, coming back to my academic journey, before coming to University College London and working as a board member of South Australia Government's Renewable Energy Board, I was lecturer at University of Dundee, Scotland, UK. And while working at the University of Dundee, Scotland, my responsibility was that to develop new bachelor program in renewable energy and postgraduate program, especially for the industry professionals on renewable energy. So I did that work very successfully, in which the focus was that how we have to change the domain knowledge of electrical engineering to get it more focused on sustainable electrical energy technologies. And when we are talking about sustainable electrical energy technologies, and within that context, how we have to include information communication technologies for integrating them, those courses were also integrated in that bachelor's and master's program while working at University of Dundee, Scotland, and I was responsible for that. And while working at University of Dundee, Scotland, I was lucky to get some externally competitively funded research project also. I will share them with you also. One of the project, it was funded by Engineering and Physical Sciences Research Council UK. That project, it was focused on the developing country and by taking into account the special case of our Indian condition, in which the idea was that if we are going to have renewable energy system within, let's say, off-grid area, then how we have to find out techno-economic optimum sizing of the renewable energy system for fulfilling the local demand of that system by taking into account the local availability of the resources, local availability of the energy pricing, and local availability of the infrastructure. So you see that project, it was in the year of 2007 or 8. So that work which I did long back, right? So based on that work, then recently I had 3 projects, and within that 3 projects, the focus was that how we have to integrate such type of distributed energy system within the main grid using information communication technologies and taking into account the centralized approach in which the decisions will be made by the virtual power plant centralized by using the continuous data collection from the users, and how we have to use that data within the considering the security of the data as well as the privacy of the user, and based on that data how we have to do the prediction analysis and developing the demand side management scenarios. So you see, so the domain knowledge which I got, let's say in early 2008 through a project, that have been incorporated in the recent project which was funded by the European Union, in which we use machine learning for the prediction as well as the control system, security and privacy also, not only from the decentralized point but the centralized point also. So I will share with you, because we are here for 5 days, so giving a focused lecture on that project and how we have to use this machine learning techniques for such type of projects also. Okay. So that was a little bit background from the University of Dundee, Scotland, where I was working. And before coming to University of Dundee, Scotland, I was working at University of Jyväskylä, Finland as a research director. So that was a wonderful experience for me. And the learning from that experience will also help you and how the academic environment or the teaching environment, it works in the Nordic countries of Scandinavia. So when I was working as a research director at University of Jyväskylä, Finland, which was almost like a full professor position because I had that credential at that time, and research director position, it was on that level. So here, this education program for which I was responsible at the University of Jyväskylä, Finland, it was divided into the 3 parts. One part was the teaching, of course, we had to teach the young generation. Second part, it was related to the research also. And third part, it was more or less to engage the community. It means demonstration. Teaching, research, demonstration. And that demonstration through the society engagement. Okay. So in this, I worked there for 3.5 years. During 3.5 years, we developed the master's program in renewable energy. We developed the sustainable energy technologies demonstration for the community, and then of course the research. And this development or the implementation or demonstration activities were funded by European Union Regional Development Fund. And then that one was from the, let's say, demonstration point of view. Then I will come from the teaching, because most of us from the teaching are academic background. So in the teaching, right, this multidiscipline renewable energy program, it has a 3 domain. One was related to the technology, second was related to the environment, and third was related to the economics and the policies also. So you see how the students, they were integrated, right, in which they have more flexibility based on their academic background and interest to select the subject, whether, of course, from the technology, whether they want to learn from the environmental side or they want to learn from the economics and policy sides also. And here the professors have the complete academic freedom. I mean, complete academic freedom means you have full freedom to design your course, you have full freedom to design the timetable, you have full freedom to select the which lecture room you want to have, and you have the full freedom to evaluate the students. There is not any type of bureaucratic regulations on academic knowledge and the dissemination from the professor. So that really I like, and I have not seen such type of academic freedom while working in many of the international universities also. And the students, they were so honest and integrated. Always in every class you will find 100% attendance, right? So that one was, let's say, from the teaching. Just I'm sharing some background. You should be aware that how the teaching it works in some of the Nordic countries. Then at the same time, then I mentioned you about the research and demonstration. So having some domain knowledge in hydrogen energy technologies, right? And now we have seen that Indian government is also pushing towards the hydrogen economy vision. And it has a big target now, right, to use hydrogen as an energy carrier. So while working at University of Jyväskylä, Finland, I had the opportunity to develop. I will share that experience also in a very detailed manner, but just now, because it is an inaugural lecture also, just to create your interest and to have some background. So here, integrated renewable energy system in which the energy storage in the form of electrolytic hydrogen have been considered. So now here you can see how we are using the different domain knowledge today. When we are talking about electrolytic hydrogen, so naturally it is a chemical engineering process. When we are talking about the renewable energy, some mechanical, some electrical approach is there. But when we are integrating them using power conditioning devices, so we need to have the expertise from the electronics components also. And then when we are collecting the data, right, so of course we have to analyze that data, so we need the persons for having the domain knowledge on statistics also, and of course then we may do that analysis or synthesis of the data which have been collected, maybe centrally or maybe in the somewhere on the server. So of course then we need to have some communication knowledge also, and then of course when we are doing some analysis of the collected data, we need to utilize some of the algorithms also, and then based on those defined algorithms and taking into account the different conditions into account, we need to make the decisions also. So some of the decision will be based on machine learning also. So while working at University of Jyväskylä, Finland, I was mentioning that to develop, I was responsible to develop a system in which we are integrating different renewable energy technology by developing different type of power conditioning devices, right, to store the energy in the form of electrolytic hydrogen, right. And then when we are storing the energy in the form of electrolytic hydrogen, right, then we need to utilize that also. So for that, in cooperation with local technical college, we developed a single passenger hydrogen fueled car also. So you can see that to develop a single passenger hydrogen fueled car at what time in early 2000, right? So it was a big challenge, because at that time none of the leading automobile manufacturer were producing the hydrogen fueled car. But now we know that many of the leading car manufacturers, for example Toyota, Hyundai, they are marketing or demonstrating hydrogen fueled car also. So at that time the idea was that when we are talking about sustainable energy technologies, so when we are storing the energy in the form of electrolytic hydrogen, how we can utilize as a fuel in a single passenger car, right, especially in the Nordic climatic condition. So that work I did when I was working as a research director University at Jyväskylä, Finland. Okay. And I will share detailed experience with project description, single line diagram with you also, so that you can also learn about sustainable technology development. Okay. And before coming to University of Jyväskylä, Finland, I was working at Hydrogen Research Institute, University de Quebec, Quebec, Canada, where I worked around 2.5 years. And during that 2.5 years time, I did a lot of research work on green hydrogen energy technologies. So the work which I did at that time, let's say 25 years before, now that work is picking up, and in almost most of the all leading countries in the world, they are developing their energy policies, making towards hydrogen as an energy carrier, and then that hydrogen should come from renewable energy technology. So I will share with you my detailed working experience at Hydrogen Research Institute, so that you can learn that, and you can see that by getting some learning from Farooq also, how you can use machine learning techniques for managing such type of energy systems also. And before moving to Canada, I was working at NIT Bhopal, and that experience was also very good. And at that time, my main focus was on electromechanical energy conversion, and I was teaching at that time generalized theory of electrical machines also, energy economics and planning also. And then before that, then I was at IIT Delhi, and sometime I worked with Government of India for few months as a technical consultant on energy conservation and management. So that was my little bit academic picture. So I graduated long back in 1989. So I'm quite old man, and I moved out of India from early 2000, let's say, and from early 2000 then I'm just contributing heavily with international cooperation, collaborations on sustainable energy technologies, and how this sustainable energy technologies operation and the data can be integrated using artificial intelligence for energy efficiency and management also. Few years before, some of my PhD students, they used the machine learning applications for energy prediction, energy efficiency and demand side management also. I will share that experience with you. Now moving forward, when you are working in international universities, so it is quite different to work or to have the work culture considering the Indian conditions into account. So whenever we want to do the research in any international universities, we have to find out the external funding. And to get the external funding, it is not very easy, it is very challenging, very tough competitive process, success rate always under 10%. So while working in all these international universities, most of my research work have been funded by these different research councils. While working in UK, my research work, it was funded through competitive process through Engineering and Physical Sciences Research Council. Some of you may be aware that to get the competitive grant from the EPSRC is quite tough. Success rate under 5%. So let's focus on first EPSRC UK. What was that? So I will just give you a little bit idea. Okay. So when I was working at University of Dundee, Scotland, in cooperation with 2 UK universities plus 2 Indian organizations, we made a proposal that how we have to develop off-grid energy system for developing countries, for example like India. And not only that, but when we are going to have off-grid electrical energy system with more focus on sustainable energy technologies, then such type of system is going to need to have appropriate community engagement also. And of course, we need to take into account the available resources, available local energy consumption for making them more self-sustainable. In short, we can call it Urja Swaraj or energy independence, right? So for that, how we need to work on developing the architecture, right, in which we can have this off-grid electricity system integrated. So in this off-grid electricity system, what we considered here, I will explain you briefly here. So for a local condition, we want to develop the off-grid system here. I am going to share a detailed presentation about this also, but just now I am trying to give you a little bit high-level overview to create some interest or in you. So when we are talking about the off-grid system, and within this off-grid system, we have to consider how the resources they are available at that particular location. Based on the available resources, and of course by taking into account the profile or the load profile of that local community into account, okay, and then at the same time with these local conditions, we have to consider the local economics also, because we want to make the sustainable development of this community. So the economics plays a very important role also, and considering the local load profile, economics and the resources, then we have to find out the optimum sizing of components which are required for this off-grid system. Now, when we want to do this one, it is not that easy, right? It is not that easy. Now here I will try to explain you how we can use machine learning for this approach. Okay, and for will teach you much more in depth about some of the techniques also, and as time permits I will also teach you, don't worry. Okay, so but today we are at the starting. So when we are talking about the optimum sizing of the components which were going to be required for this off-grid system, taking into account the local resources, profiles, etc., that have been covered when I was working at University of Dundee, and then we got the funding for this project, right, through EPSRC, and you can see that funding was around 2 million British pounds. So now here, when we are talking about this optimum sizing of the system components, right, so when we have to develop this project or decentralized or grid energy sustainable energy system projects, so naturally we have to take into account the technical or lifetime of this project. Let's say technical. So let's say if we take into account such type of off-grid project is going to remain, for example, let's say for the 25 years, for example. So within this 25 years, we have to make a plan that whether the system is going to remain the off-grid or going to be grid connected also. So naturally, economic conditions are improving, right? Technology is also improving. So there may be possibility that before the end of this technical lifetime of this project, this off-grid project may get grid connected also. Okay, so due to that, the economics is going to be changing also. Right. So now let's say when we want to design this off-grid system, taking into account the local available resources as well as the load profile also, how we are going to do that one and how we can utilize the knowledge of data for, let's say, with the first objective of finding out the optimum sizing of the system components. How you are going to do that one. Now here it comes, you have to rely on the available data for that particular location. Some of the data may be available locally, but we know that in the world, many countries, they are not properly developed, developing, may not have the appropriate data available. So we may need to rely on the data available through the satellites, for example, from the NASA or so on. So when we are collecting the data for that particular location, right? So those data may be historically available. So for example, at this particular condition, if we are taking into account the hydropower potential, for example, so we may have some information, right, how the hydro resources are going to be available there. But we know that due to the change in the climatic conditions, the rainfall patterns are also changing. Right. So now you see, we need to use the machine learning for predicting the available resources for that particular location, and those resources, when we are planning here this project for 25 years, so we can see that based on the historical data, how we can do the prediction of the resources, right? So I have given you one example of the hydropower or the rainfall patterns that is also changing with reference to the climate change patterns and many things also that is going to impact the operation of such type of off-grid system if in which we are connecting the hydropower also, and then hydropower is going to be the sustainable energy technology. So you can see that how you can use your machine learning techniques for operation as well as designing of such type of systems. So here just I try to give you a very high level example of off-grid system. So it is not only from the solar rainfall patterns, but also where depending on the location, we may consider the solar also, right? So here also with reference to the solar, we need to do the analysis based on the historical data and to get the prediction for the next couple of years also, how we are going to predict the solar radiations also. In the solar radiation also, of course the solar geometry is going to play the major role, but in addition to that, here I am trying to explain you that how we can use the machine learning techniques or AI techniques for it. So if we are considering the solar here, right? So because all these factors have been considered in this project, that's why I'm explaining you here. So in the solar, let's say, because we need to know the local resources available. So for that local resources, let's say if you take one condition of the solar, so here we may have three components into account. One, direct component, diffuse component, and ground reflected component also. So here, direct radiation that can be estimated, but that direct radiation, incident direct radiation at that particular location going to depend on many other parameters. For example, climatic conditions, if we are going to have a lot of clouds, right? So during rainy season or during non-sunny days, we may not get the direct radiation. So to